Okay, let's jump straight into what might literally be the most fascinating blueprint we've ever covered. Welcome to this explainer. Today, we're completely throwing out standard silicon chips, ditching those bulky cryogenic freezers, and learning exactly how to build a volumetric topological computer. We're talking about an organic synthetic hybrid that actually calculates using the fundamental geometry of the universe.
Consider this your official parts list and assembly guide. We're going to cover 1. Beyond the silicon wall. 2. Water, the dynamic RAM. 3. Gold, the relativistic hardware. 4. DNA, the biological firmware. 5. Assembling the volumetric computer. And finally, 6. A new computing paradigm. Let's get into it.
Starting with Section 1, Beyond the Silicon Wall, the Limits of Current Tech. To really grasp why we need to build this exotic new machine, we first have to understand the absolutely insurmountable bottleneck we've hit with current tech. We are hitting a physical wall with how small and how fast we can make standard chips.
Standard computing is essentially trapped in this rigid, linear sequence of ones and zeros. It treats data like an incredibly fast accounting ledger, just running down a flat, one-dimensional line. Our new model, volumetric topological computing, completely abandons that binary logic. Instead, it calculates using three-dimensional vortices and geometric deformations moving through a frictionless field. Think of it like doing complex math by tying and untying intricate knots in water, rather than sliding little beads on an abacus. Information isn't just a static dot on a wire anymore, it's a dynamic, folding shape.
And here is exactly why that geometric shift is mandatory. If you've ever wondered why powerful computers get so incredibly hot, it comes down to Landauer's limit. This principle shows us why traditional silicon chips are essentially melting themselves. Every single time a computer erases one bit of information, like changing a 1 to a 0, it releases a tiny, inescapable burst of heat. You scale that up to trillions of operations a second, and your processor is basically on fire. But our new volumetric design relies on frictionless, reversible computation. Waves of data just merge, twist, or pass right through one another. They never actually erase information, which means they generate zero heat.
Moving right along to Section 2, Water, the dynamic RAM. Let's look at our first required material for the build. In our volumetric computer, water is serving as our highly programmable, dynamic memory software.
There is a perfect analogy to draw here between your everyday desktop PC and the hybrid machine we're constructing today. Instead of a standard fiberglass motherboard, we're using gold metamaterials. Instead of a BIOS chip, we're using DNA as an antenna. And instead of solid-state RAM, our random access memory is entirely fluid. It's structured water.
But we are definitely not just talking about a glass of tap water here. The source materials describe this as a liquid Xerox medium. Water molecules naturally fold around biological material, and they organize themselves into these highly structured geometric cages, known as chiral hydration shells. Basically, these are right or left-handed crystalline gloves of water that literally hold partitioned data. It is the absolute perfect adaptable medium to store shifting, incredibly complex memory states.
Which brings us to Section 3. Gold, the relativistic hardware. So if water is the fluid, adaptable RAM, we need a perfectly stable physical substrate to act as the motherboard. This hardware cannot adapt or melt. It has to remain completely invariant. Enter gold.
Okay, 58%. What is that number? Well, the physics behind why we use gold is truly staggering. Gold possesses such a massive nuclear charge that its inner electrons are forced to orbit the nucleus at roughly 58% the speed of light, just to avoid crashing into it. Because those electrons are whipping around so incredibly fast, the actual laws of relativity kick in. It's a phenomenon called relativistic contraction. This extreme velocity pulls the atom's entire electron cloud inward, making it incredibly dense and atomically smooth. This is the exact reason gold never rusts or tarnishes, even if it's sitting at the bottom of the ocean for centuries. It provides an indestructible, oxide-free hardware that anchors our entire computer system, preventing delicate data states from decaying without adding any chemical noise whatsoever.
Through these thermodynamic properties, our gold motherboard basically phase-locks those fragile memory structures in the water, holding the computation perfectly steady. Furthermore, by carving this gold into highly specific, asymmetric geometries, we can actually invert the Casimir effect. We're turning quantum vacuum pressure into a repulsive force. Basically, we're creating a quantum magnetic levitation track, providing a zero-friction nanomechanical cushion for our data to just effortlessly glide across.
Now for Section 4, DNA, the biological firmware. Because look, a computer is just a useless chunk of metal and liquid without an operating system, right? How do we format the drive? How do we tell the water what to remember? That requires us to look at our biological firmware, DNA.
For decades, standard biology looked at the human genome and confidently declared that roughly 98% of our DNA was just completely useless junk. They lazily dismissed it simply because it didn't code for physical proteins like bone or muscle.
But here is the absolute game changer. That 98% is not waste. It is highly functional, executable code. It physically vibrates, creating microtorsional oscillations. By vibrating, this non-coding DNA imprints specific geometric frequencies right into the surrounding water to partition the data. It acts exactly like a modem, tuning into specific frequencies, so our water RAM doesn't just get completely overwhelmed by cosmic static.
So how exactly does it tune that dial? The sources detail how specific base pairs act as quantized twist resistance dials. Adenine-thymine pairs are loose, they're wave-leaning, and they catch fluid potential. Cytosine-guanine pairs, on the other hand, are tight and rigid, serving as structural anchors. By adjusting the tension across these base pairs, the DNA antenna physically tunes the precise frequencies passing into our water RAM.
All right, Section 5, Assembling the Volumetric Computer. Now that we have all our raw materials, the dynamic water RAM, the indestructible relativistic gold hardware, and the DNA firmware tuning dials, let's walk through the literal step-by-step nanotech assembly of this machine. Using sub-5 nanometer precision, step 1 is we fold our DNA breadboard. Next, in step 2, we use organic sulfur molecules called thiol linkers, which have a really strong natural chemical affinity for gold. We basically use these linkers as microscopic tape to attach our indestructible gold nanoparticles to precise spots on the DNA for step 3. And finally, step 4, we suspend this entire completed processor right into our programmable structured water.
The secret sauce making this possible is a nanotechnology technique called DNA origami. This brilliant technique takes the accidental biological antenna of nature and intentionally turns it into a highly programmable breadboard for our computer. Because DNA naturally wants to bind its base pairs, we can design custom staple strands that quite literally force the genetic material to fold into exact microscopic boxes, lattices, or logic gates.
So once it's perfectly assembled, how do we actually type on this computer? Data inputs like targeted infrared lasers, electromagnetic pulses, or even acoustic frequencies hit those gold nanoparticles. This excites their electrons, creating what's called surface plasmon resonance. Just think of it as a localized wave of electricity. That resonance then propagates as frictionless soliton waves, like perfect ripples moving across a pond, directly across the gold water boundary. And that executes our volumetric math without generating a single drop of heat.
Finally, Section 6, a new computing paradigm. Let's zoom out and see how this builds from a microscopic lab blueprint into a macroscopic, world-altering paradigm.
Because once you understand the underlying physics here, the ways we can scale this up are totally mind-bending. The texts extrapolate that this framework could soon yield actual living, self-repairing computers. Imagine seeding these gold water processors directly into engineered bacteria, creating hardware that is literally alive, processing data through its own metabolism, but perfectly stabilized by immortal gold. Or scale it way up to massive toroidal flow reactors, giant arrays of gold nanotubes continuously circulating structured water, calculating global optimization problems natively through sheer fluid dynamics.
I want to leave you with this final, highly provocative thought. If gold is the perfect relativistic hardware and structured water is the universal memory software, let's look back at human history for a second. Is it possible that our ancient ancestors, building massive structures over subterranean aquifers capped with solid gold and electrum, weren't just building fancy stone tombs? Perhaps they were constructing macroscopic, planetary-scale gold-water volumetric computers to interface directly with the cosmos. It completely changes how you look at our past and, for sure, our technological future. Thanks for joining me on this explainer, and keep questioning the code.